Let's go ahead and take a look at a couple of the derivative rules. And the first one is going to be the constant rule. We know that the derivative of a constant function is going to be 0. Right? When you think about your constant functions, those are horizontal lines. So the slopes of those lines are going to be 0. Right? The rate of change of that constant function will be 0. Right? So if we take just a basic equation like y equals -2, right? The -2 would be a constant function. So if we go to take the derivative of that constant, right, we should get 0 as an answer. And so when you're talking about notation here, right, my function was y equals -2, so y prime in this case would be equal to 0. Right? That would be our derivative. You might also see the notation d over dx. Right? This is taking the derivative with respect to x of our function, which in this case would be 2. Right? So ddx of -2 would come out to be 0. In this next example, let's go ahead and take a look at the power rule. This is probably one of the ones that you would use most often. When you're working with the power rule, right, you're going to have terms like x to the 4th power, you might have other exponents, you have x to the 7th, x to the 400th, it doesn't necessarily matter. Right? Whenever we're working with a power function, the exponent is going to come down in front. You'll keep your variable, in this case the x, and then you're going to be subtracting 1 from your exponent. So we'll have 4 minus 1. So this is going to give us 4x to the 3rd. And that would be our derivative of x to the 4th power. And then keep in mind when we're talking about functions, you could have a combination here of terms. Right? So we have a rule in case we have 2 terms or 2 pieces that are being added together. Right? We have a rule in case they are being subtracted. Right? So we have a difference rule. And we also have what's called a constant multiple rule. Right? Some function being multiplied by a constant. And so let's kind of go over each one of these. If we're talking about the sum, right? We have 2 functions maybe that are being added together. I could go ahead and take the derivative of each term. And I can do the same thing if I was subtracting 2 terms. And I could take the derivative of the first term minus the derivative of the second term. And then when you're talking about your constant multiple, right, you can pull that constant out in front and then take the derivative of the term that is left. So let's go ahead and take a look at each of these. And we'll just talk through one example. I think we can cover all 3 of those rules with this function. We have f of x equals 2x cubed minus 6x squared plus 3. Right, and so you'll notice that on our first term here, if we want to take the derivative, you have a couple different notations you can use, right? We've got the f prime of x, or you can use that d dx, right? Taking the derivative with respect to x, and you can apply it then to both sides. Right? The derivative of f of x, and we will do d dx, the derivative with respect to x, of the entire right-hand side, which would be 2x cubed minus 6x squared plus 3. Alright, and so let's go ahead and just focus on this right-hand side. Notice that these terms are being either added or subtracted together. Right, so we can use those sum and difference rules. So this would be ddx, or the derivative with respect to x, of 2x cubed minus the derivative with respect to x of 6x squared plus the derivative with respect to x of so this would be using the sum and difference rules. Now notice that some of your terms here have a constant out in front as the coefficient. Right, we can go ahead and use that constant multiple rule and pull those numbers out in front. So in this first one, I'm going to take this 2 out. And that's going to leave us with the derivative with respect to x of x cubed. In our second term here, I'm going to go ahead and pull that 6 out. And we'll be left with the derivative with respect to x of x squared. And then I'll keep that last one there, the derivative with respect to x. So this is using your constant multiple rules. And now let's go ahead and use the power rule. Right, notice you have x cubed here. We can bring that exponent down in front. So I'm going to keep this 2. Right, the 3 is going to come down in front. I'm going to have x to the power of 3 minus 1, which is going to give me an exponent of 2. For the next term here, I've got my minus 6. Right, if we're looking at the x squared, we can also use the power rule. The 2 is going to come down in front. I'm going to keep my x, and for my exponent, I'm going to have 2 minus 1, which will give me a 1. So these are using the power rule. And then you'll notice on this last one, right, we're taking the derivative with respect to x of 3. 3 is a constant, right, so that's going to give us a 0 if we take the derivative. And let's go ahead and simplify our answer here. This is going to give us 6x squared minus 12x, right? I don't have to write the plus 0. So this will be our derivative. If you want to write this as f prime of x equals 6x squared minus 12x, you can do that.